Hey guys, it's Ian. If you know me, you know that I started this year with a New Year's resolution to create and demo three of my personal programming projects, and I did this partially to show off the things that I find neat and maybe other people will find neat, and also partially just to hold myself accountable, of course. But I wanted to start with something super basic and super small, the Mars rover that landed recently. And for those of you who don't know too much about the Mars rover, it actually landed during the deployment phase. It deployed this parachute, which some smart people on the internet discovered actually contained this message that says "Dare mighty things," working from the inside out, saying "Dare mighty things." And each of these is encoded with a letter converted to a sort of binary, and going on from that. So the way that NASA encrypted this, they have a direct correlation between what letter of the alphabet it is to the binary value. So we see D, and if we look at this, we see that D is the fourth letter of the alphabet. So if we look back at this and we look at the binary values, if you're not familiar with binary's a sequence of zeros and ones, and it works with 2 to the power, starting with 2 to the power of 0, and as it increases from right to left, it increases exponentially. So it goes 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and when we think about that as actual values, it's going to go 1 if set, 2, 4, 8, 16, 32, 64, and it just keeps doubling. But the way that you can count up is if you have both the first and second one set as 1, that's 1 plus 2, so that's 3. So to go back to this project, if we see dare, and we think about this D again, fourth letter of the alphabet, we know from our binary explanation right there that the fourth letter is 1, 2, 4. So we would expect this 1 to be set, and we would expect zeros everywhere else. And if we look back at this, we can see that that's the case, right? So we see this 1 being set, and this is 3 from the end. We see zeros following it, and we see zeros before it. And if we want to confirm it again with this A, we see all zeros here, and we see this last value set, indicating the 1. That is the first letter of the alphabet. But my project's a little bit different in that I use the ASCII values. So with ASCII, each letter has a different representation in the ASCII table, and it differs based on if it's capital or lowercase, so it'll differ in my program as well. But where they used A indicated by just 1, we're indicating it with 65. So when we do our validation, we'll compare it with these ASCII table values instead. But to jump into the project, we can see just kind of like a bare bones HTML, CSS, JavaScript project, and we can see this encoded message that right now is set to space is neat. So all of our values start at the 3 o'clock position. So if we think about each of these letters being represented by 8 different values, either set to 0 or 1, then we know that a 5-letter word would make up a ring with 8 times 5, which is 40 characters. So we'd expect 40 different slots in this outside spot. So we know, based on that, that S would be 0, 1, 0, 1, 0, 0, 1, 1. Of course, 1's being indicated by the red or the primary color, white's being the 0 or secondary color. So again, 0, 1, 0, 1, 0, 0, 1, 1. And if we confirm that with capital S right down here, we see 0, 1, 0, 1, 0, 0, 1, 1. And if you were to add those up, that comes out to 83. So just to validate, we see that this first space, the S, makes sense. If we kept going on, we would see that the rest of the values are also correct. And then we see 3 rings because there's 3 separate words. So another thing that I incorporated was I graduated from Ohio Northern University. And I know that their colors are kind of like this orangish and a black. So I wanted to increase the kind of design aspect and be able to create different colors. So we see that this Ohio Northern University, you can change the color and it changes the circles. And the same type of way, Starting with this kind of 3 o'clock position, we see 0, 1, 0, 0, 1, 1, 1, 1. 0, 1, 0, 0, 1, 1, 1, 1. And that's the capital O, so we can confirm that 0, 1, 0, 0, 1, 1, 1, 1. And that all looks good as well. But one of the other things that I noticed was as you get these larger letter words, especially toward the end, it's kind of super small and you can't really tell what all of these factors are. But if we increase the height or the width or both, we can actually increase essentially the resolution. So if we make this a little bit bigger, it's a little bit more legible. And the other nice feature about this is you can easily copy and paste it. And it's a lot easier to shrink a high resolution image than to expand a low resolution, right? So if I want to show you just the copy paste functionality, we can jump over to this demonstrations table real quick. And we see that if I paste this in here, then we see, of course, it scales it down just the way that Discord does. And we see Ohio Northern University, of course, with a transparent background. So all of this I felt was pretty neat and wanted to be able to demonstrate it. So it's currently hosted on Heroku. Wherever I'm posting this, I'll make sure to include the link. But if you want to give it a try, feel free. I have no clue what the limitations on Heroku are, but hopefully you get a chance. Thanks for sitting down for this demo, and hopefully you guys can get a chance to look at the next one in a few months.